and thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBB Electronic.
Welcome to the Passion for Technology podcast. Data is at the core of digitalization, as is digital drivetrain technology. In this episode, we'll be talking about what you can do with digital drivetrain technologies beyond just controlling a motor.
Our guest today is Armin Wallnöfer, who is leading the Smart Lab for ABB's Motion business. ABB Motion is offering drives, motors, generator products, and integrated digital powertrain solutions. Hey, Armin.
Hi, good to be here.
Well, great to have you. Armin, what type of data does a digital motor control system capture?
As a user, your main pain is keeping your system or a machine up and running. That means you want to know about mechanical health and also about the electrical health of your system. So you want to keep a pump pumping water, for example. And that's why you want to know everything that this pump is keeping, what you should do, pump water. And for that, you need to know, in the background at least, what's the mechanical situation of it and also what's the electromechanical situation of it. And by that, you need then maybe to know about the currents, voltages, vibrations, temperatures, humidity, environmental conditions, and whatnot. And this monitoring system helps to capture exactly these and put them into the context of your reality as a user and telling about this health status of your application. And also, it's not enough to just look at the motor. In modern installations, it's mandatory to also use variable speed drives most of the times. And that means the variable speed drive itself, so a frequency converter in other terms, is running and controlling also the motor, and also interested in the health status of that device. And also the variable speed drive can be used to collect data about the motor itself. So the overall system of this electrical powertrain, how we call it, is important.
All right, so that's the type of data. And how can this data be made useful or, let's say, usable in the first place? What do prerequisites look like to tap into this kind of data?
Yeah, usable means you have to look at the user, right? And the value for the user. So as a user, I want to know, is my application up and running? And is that also reliable in a way? So can I count on that? So for example, if you're running a chemical plant, you want to know that the steering is working in your process, so to say. And the crucial part of such a steering application, for example, is the movement of the rotator, the motor itself. And that's why at the end, you want to know about currents, voltages, vibrations, and all these kind of things around electrical and mechanical systems.
You mentioned reliability. In many applications, I think it's safe to say that the reliability of the drivetrain is paramount. How can I use that data, the data in digital motor control, to, let's say, identify errors early, maybe even to prevent failures?
So there we're not talking so much about motor control. And motor control is typically the real-time controlling of a motor, of a movement, so to say. We're rather in the area of monitoring here. That means you want to monitor the condition of these devices, right? In that, you collect again the data and then you try to do predictions. First of all, you look at the current status, but there are some faulty statuses that should not be there, high vibration, for example. And also you try to extrapolate then a future behavior of your devices, doing predictions. And that's maybe the new aspect of it. The topic itself is decades old, but the new aspect is really IoT, that you collect more data, historical data, and that you can then build your statistical models around it. And also with the means of AI, you can then try to do predictions around that.
So you're mentioning predictions, and I think the term in this context that I've heard is predictive maintenance. So there is a lot of talk about it. What data from the drive, beyond, for instance, the vibrations that you mentioned, can be used to enable that type of predictive maintenance?
It's again an old story, actually. So using current data, you use voltages, you use vibrations that you can derive from, say, the electrical signature of these devices. And you capture them, and then you know what's the normal status. And you can then detect abnormal situations or anomalies in that sense. It's often you look at timely manners or like over the time, how these parameters are then changing. And by that, you can then derive a trend, for example. Let's keep it simple. You look at the motor, for example, using also the drives data. So a drive is connected to the motor, right? Running the motor. And by that, the drives knows exactly what the motor does and should do. And You also get the feedback from the motor. Even if you not use an encoder or so, the modern drives, also the ones from ABB, can do that in an open loop setting. But from the torques that you're deriving and measuring or predicting, and also the current data, current signals, can then tell, okay, is the motor behaving like it should, or is the behavior changing over the time? And that is an indication that something is going wrong. To enrich maybe to build on your question, to enrich these analytics, we also introduced a thing called Smart Sensor, which is a measuring device that you put on your motor in addition to the drive. So to the frequency converter, you then have a separate box that is then monitoring, for example, the magnetic field, vibration, temperature of the motor. And by that, you can then much more closely, say, monitor the motor and also then do much better predictions about, for example, if the bearing is getting worse or whether you need some greasing of the bearing itself.
So, I mean, that helps. That helps with understanding how you can derive insights from raw data, comparing normal motor operations to abnormal data that you collect. Do you help customers with this?
Yeah, there are different ways. I mean, ABB is selling directly to end customers, and also our services are provided to end customers directly. In that field, just a year ago, we launched a service that is called Monitoring as a Service. So end customers can buy like the monitoring itself from ABB. That means we have an eye on to those connected devices, and we do exactly this analysis I just mentioned. Have a look at the status quo. Is everything in shape and well running, or is there something building up slowly and we get an indication, you might need to act and do some maintenance in the coming weeks or months in order to avoid a failure or breakdown or downtime of your site. But we also use our partner networks for that, especially globally. I mean, every market is different. And in some markets, we also have a big channel through our partners, and they also provide these services to their customers. So they then use rather our digital solutions as a platform and then provide what they do also in a digital manner, in addition to the traditional services that they do anyway, which is then measuring motors or like going to the field, measuring the motors there, or also, doing repairs in the field. You can then just enhance possibilities you have in a field service with digital means.
I find that very exciting. I mean, which other services can be implemented on the basis of, drivetrain data?
I mean, all these predictions I just talked about, or let's call it data analytics. Predictions is not always the case. It's more, you want to look for anomalies. This, in most of the cases, the thing you're interested in, right? As your machine or your plant or site is up and running, nobody cares. You want to get early indications if something is going wrong. And these indications you either get from what I just explained, right? Monitoring and looking for trends. But what we also do, for example, we have solutions in place to monitor wind farms, right? So let's say they're in the Baltics, you have a wind park consisting of 50, say, windmills, and you then just compare how they do and what they do. And then maybe one out of those 50 is having a different behavior, right? It's the same wind that is blowing there. It's the same temperature. It's the same humidity and everything. But one acts differently or maybe weird. And that's an indication something is wrong. And that could be then a reason to send somebody out in a helicopter. And of course, this is expensive. So you want to go beyond just telling, okay, something is weird there or something is abnormal. You also want to do then the remote analysis and troubleshooting. And that's also a very important field that is sometimes overlooked in these discussions. At the end, the customer just wants to have his site and machine up and running, and troubleshooting is the essential part for that, right? So it's not always about fancy data analytics. It's most of the times just fixing the problem. And for that, you need troubleshooting possibilities as well. And that means easy ways of gathering the full picture about the situation in the field, backups of parameters that have been used to configure the drive, for example, and such things. What you also offer is a thing called remote visual guidance. So using augmented reality so that the technician in the field, which is maybe not like the drive expert or the motor expert, still gets some, say, big brother or big sister looking over the shoulder and supporting the guy or girl in fixing the problem, or first of all, understanding, and then later maybe also fixing the problem. And such digital tools are also helpful and important in reality.
When you look at these higher level services, at these refined services, would you say that users, customers are ready and willing to pay for that? I mean, can a company use, something that's essentially built on data from drivetrains to generate additional revenue?
I mean, there are proofs out there. If you just look into the market, I mean, startups are all over the place and also in that field. And in the last decade, you can tell that there have been a number of startups exactly seeing the potential in the data that is now accessible through the IoT much more easily than before, right? Before you had just these on-premise solutions and data somewhere stored on local servers or computers or PLCs. And nowadays, you see a lot of those startups. And also one of them just recently partnered, as it's called, like they are called Samotics, and their business model is using the data, doing predictions, doing anomaly detection, and by that creating value for the customers by avoiding the downtime. Yeah? And they are living from it, and they have dozens of employees already. And I think that's a good proof that you can do a living from it.
I mean, pay-per-use is another buzzword in the context of, first projects that are using in-depth insights into drivetrain operation. Can you explain the concept to us?
Pay-per-use is a concept in a bigger context, so to say. So the overarching term is outcome-based business models. Sometimes it's also referred to as everything as a service. A concept known like from the software industry or also in private, right? Everybody's streaming music and not buying CDs anymore. So you rather buy for the availability of something, or accessing something, using something. And also pay-per-use is one of those concepts. Typically, you'll find that, and it's nothing new, right? Car rentals are there since long, right? Or if an equipment is just too expensive, you can rent these things, a crane, for example, yeah? And while you find also these concepts in industrial applications that you don't buy the equipment as an investment, but rather go into leasing models and that. But as I said, it's nothing new. And also the funny part, the valuable part for customers comes if you go beyond. And you see also new models coming up where the vendors of the devices or the manufacturers of these devices or equipments also take the risk with the customers and going into, they just earn money if the equipment is up and running and delivering. So this is then the outcome-based aspect of it. And also you see really a trend. It's not a majority of applications which is now sold via that, but it's coming more and more because somehow you not only promise as a manufacturer, like my equipment is more reliable than the one of the competition, you also say combine it with the payment, right? The customer is only paying if it's really delivering the value we are promising. Where we, for example, look into energy efficiency topics, and you have companies out there like the ESCOs, right? So that are selling energy savings. Those companies, they go into sites and then they do an assessment and audit about what is the light, what devices are using to produce light. Is it the old light bulb or is it LED? So, and this is like in the context of pay as you use or pay per use. These are models that are going beyond and that are also more valuable to customers than just a pure pay per use model.
That really helps with understanding what the benefit for customers is. What would you say do drivetrain manufacturers get out of it?
Yeah, I would say mainly customer loyalty. So you rather apply not this one-off payments, transactional business models, but rather subscriptions. So binding the payments to the outcome, which is much closer to the value of the customer. And of course, you do then everything to keep that customer and keep that subscription going. And that's a much closer connection that you have at the end with the ones using your equipments.
These additional services are usually thought of in terms of industrial applications. What does it look like in other markets, let's say e-mobility, for instance?
I mean, these models are coming also from other markets, right? So car rentals. And they somehow found their way into these industrial areas now. And on a large scale, the first one applying it was Xerox with the copy machines, right? Or also very well known is Rolls-Royce with these turbines, aircrafts. So basically, there's a tendency that the value is now materializing more and more into business models. That means you put the value in the center and also bind the payments to that. Also, I believe strongly that this is like a transformation of B2B relations in general that is slowly but steadily happening there, going away from this transactional, I buy something, you deliver, towards a continuous relation between businesses and customers in delivering the value that they need.
Thank you. I mean, this was really interesting and really broad with, occasional depths. It really helped understand and get a feeling for where digital drivetrain technology is at and where it's going and who can, how the various stakeholders from customers to producers of digital drivetrain technologies can benefit from the changes that are happening there. Now, when closing this episode, I would love to understand and love to know when and how you developed your individual passion for technology. Where does that come from? How did you end up being a technologist?
Good question. I mean, as I think most of those enthusiasts, it started as a kid, right? So playing Lego, building funny machines, helping the parents in fixing stuff and disassembling whatever tools and have a look what's inside. Now, as a grown-up, what's really still keeps intriguing me about technology is I think there is no alternative than innovation, right? So we cannot just stay in the status quo. Also looking at the climate crisis, for example, technology can be, and I think will be, one of the answers to meet that, right? Just as a very efficient motor is saving energy, or a frequency converter can bring down the energy consumption by 30%, there's no alternative than using that innovation, right? Otherwise, as a humankind, I would even say we cannot survive on this planet. So innovation is mandatory and not an option here. And that's also why I'm really fond of working for this company, because we can really make an impact. And not only good business, of course, at the end also be interested in business, but really what we do and also the innovations that we're bringing will really help to make this world a better place and save it.
Thank you. Thank you, Armin, for the insights that you've shared with us today. And as always, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Armin, thanks again for joining us today.
Yeah, thanks for having me.